Hello everyone, Ms. Woolwine here. Sorry I couldn't be in class today. I'm at a meeting with some other math teachers throughout the county, getting some good work done. Today, the plan is for you to finish page 13 in the packets that we've been working on. Goal on page 13 is to get through number 10, so you'll be doing 7, 8, 9, and 10 on page 13. This is something we started last time, and the goal is to finish up through number 10 today. Most people got through 7 or 8, or at least parts of 7 or 8, but 9 and 10 I think eluded some people, and that's okay. I wanted quality over quantity, and today, finishing up numbers 9 and 10. Here are the answers. Number 9, the answer is -3 and 2. Number 10, the answer is 7 and 6. Now, I would like to see, obviously, work for numbers 9 and 10, but these are a way to quick check your answers and make sure that they're good. I will be checking page 13 when we are back in class next time. That will actually be the first grade of quarter 3. It will be a quick completion grade for 7 through 10. So make sure you have those done before next class on Thursday. As a reminder, the quarter also ends on Friday, so any work you still need to get to me, you have until Friday to do so. Obviously, I won't have Win today, but on Wednesday and Thursday this week, I will be available for Win time for any additional help on assignments, quizzes, or anything in between. Okay, but the deadline is Friday at the end of school. So, with that being said, today, you're going to finish up page 13, and then when you're done with that, on page 15, we're going to take a look at some notes. On page 15, I'll have you use some practice problems. So, on page 14, we're going to go through 3 example problems, illustrating a new way to solve a system of equations. Remember, a system of equations is are two equations that have one solution. For example, number 1. This is on page 14. I have 2x plus 3y equals 10, and negative 2x minus y equals negative 2. There's one value for x and one value for y that works for both of these equations, and our job is to find it. Now, using substitution, we might look at this and say, oh, well, we can solve the second equation for y, and then kind of plug that into the first equation to find an x, and then also go back again to find the y. It's a lot of work. That's substitution, okay, but it works. However, with a new process called elimination, I can, 1, save myself from some work, and go through the problem with a little less writing, which I think you'll all like. I look at number 1, for example, and with my math brain having a little bit of experience with this, I really like 2 things about number 1. One thing that I like is that the x's are in a row, right? The x's are right on top of each other. Same thing with the y's, the equal sign, and the numbers. Okay, so my x's, my y's, my equal sign, and my numbers are all on top of each other. Okay, that's one thing I really like. Another thing I really like is that when I look at these 2 equations, I see an opposite pair. And what I mean by that is I see a positive 2x and a negative 2x. They're opposite pairs. They're opposite because I have a 2 and a negative 2, and they're pairs because they both have an x. So I see that opposite pair, and that allows me to very easily do something that you'll see right now. This process is called elimination. That's what we're going to use. And the reason it's called elimination is because I am allowed to add these 2 equations together. What does that mean, add the 2 equations together? That means I'm going to combine both of these equations into one. And to do that, I'm going to use addition. And when I use addition, I need to make sure I'm combining like terms. And since my x's, my y's, and my numbers are all lined up, it's not too bad. And when I combine like terms, I'll take this 2x plus a negative 2x. What's 2x plus negative 2x? Oh wait, they cancel out. It's 0. They go away. I no longer have x's in my new equation. And so my new equation will just be 3y plus negative y. That's a positive 2y, because a negative y is like a negative 1y. Then equals 10 plus negative 2, that's 8. My new equation is 2y plus 8. I can solve this for y simply by dividing by 2. and we'll get y equals 4. And just like that, we have a value for y, for one of our variables. Of course, we're not done. We need to go back and find x as well. But if you can see, we eliminated the x's. That's why it's called elimination. We eliminated the x's to be able to easily solve for y with just one step. Okay? Now, however, we need to go back and find the x. And being pros of substitution by now, we can take this y equals 4 and plug it back in to one of the other equations to find x. For example, I will use the first equation as 2x plus 3y equals 10. So I'm going to write that, 2x plus 3y equals 10. But instead of y now, I'm going to go back and replace it with a 4. All I did is I took the 4 that we know is y and replaced it with y in the other equation. This simplifies to 2x plus 12, because 3 times 4 is 12. That equals 10. I subtract 12. I'll get 2x equals negative 2. Therefore, x equals negative 1. So my answer as an ordered pair is negative 1, 4, where I write the x first and then the y second. This is my answer. And as you can see, after doing substitution problems, this is a lot less work. Specifically because that first step of finding the y is very quick. It's very quick. Once we find one of the variables, we plug in to find the other. And the only reason this works is because my x's, y's, equal sign, and numbers were all lined up, and I had an opposite pair. The opposite pair being 2x and the negative 2x. When I add them together, they go away. They are eliminated. Okay? So please make sure you have all the notes down for number 1, and we'll move on to number 2. Number 2 will approach in the same way. I look to see, are my x's, y's, equal sign, and numbers all lined up? They sure are. And do I have an opposite pair? Do I have, for example, a 3 and a negative 3? They're opposites. Do they share the same variable? Yes, they do. So therefore, my 3y, my plus 3y and negative 3y are opposite pairs. So that I can add these together again. I can combine them into one equation. And my y's will be eliminated. Let's see how that works. I have a 4x plus a negative x. That's the same as a negative 1x. Which therefore, when you combine them, is a 3x. This positive 3y plus a negative 3y, they cancel out. So I'm not even going to write a y. I'm not going to write a 1y. I'm not going to write 0y. I write nothing. Don't even put your pen to the paper. I'll leave that like a little blank space right there. I bring down my equal sign, and then 6 plus 3 is 9. Okay, once again, this is for number 2 on page 14. This is therefore a very easy equation we can solve for x. This is like day 1 of solving equations. We divide by 3, and we'll get x equals 3. Just like that, we got a variable. We have x. Of course, we still need to find y, but the reason finding x was so easy is that the y's canceled out. They were eliminated when we added the equations together and we combined them into one. So let's go back and let's find y. To do so, I'm going to look at these two equations and decide, is one of them easier or more challenging to solve for y? Personally, I like the first one. I like the 4x plus 3y equals 6. Only because there aren't any negatives. That's just my personal preference. So I'm going to take 4x plus 3y equals 6. And instead of x, I'm going to replace it with a 3. And leave everything else the same. 4 times 3 is 12 plus 3y equals 6. Subtract 12 from both sides. Those will cancel, and I'll get 3y equals negative 6, and therefore y equals negative 2. I'll back away so you can see all that. Being that I have an x and a y, my answer will be 3, negative 2. Once again, the reason this works so well is that the y's are eliminated. We can easily find x. Once we know a value for x, this goes back to what we know about substitution. Once we know what x is, we can substitute that, we can replace it in one of the other equations to find y. And you have your choice, using either the first or second equation. It actually doesn't even matter. You can choose either one. I chose the first, and we found that y equals negative 2. We will do one more together. We'll do number 3. Number 3, I have 2x plus y equals 12. 3x minus 18 equals y. Now I look at this, and with my math brain, I don't really like this too much. A reason I don't like it is because my x's are lined up, but my y's and my numbers are all thrown off. They're actually flip-flopped. In the second equation, my 3x minus 18 equals y, the y and the 18 are on the wrong side. I need it such that my x and my y are on the same side, and the number is by itself on the right. And so to do, or rather fix this equation, I am going to add 18 to start to the second equation, and therefore I'll get 3x equals y plus 18, because I cannot combine a y plus 18 to be 18y. Can't do that with addition. And then I'm going to subtract y from both sides to move that back over to the left. And I'll be left with 3x minus y equals 18. Now I really like this. And the reason I like this is that if I bring down my first equation and write it right here, I notice an opposite pair. That opposite pair being the negative y and the positive y. So that if I add these two equations together, they will cancel out. They'll go away. 3x plus 2x is 5x equals, because my y's cancel, 18 plus 12 is 30. Therefore, if I divide by 5 on both sides, x equals 6. So I have to make sure this is in the right form before I can do the elimination process. Before I can eliminate a variable, I need to make sure I have an x term, a y term, equaling a number. Then I look to see if I have an opposite pair. Here I had an opposite pair. It was a negative y and a positive y, so that if I add them together, they go away. I'm left with just an equation with an x. I can easily find x is 6 by dividing. From here, I can go back to either of these two equations to find y. Now think to yourself for a moment, which equation would be easier to solve for y? Personally, I look at this and say the second one is easier. Why is the second one easier? Well, the second one already has y by itself. So all I need to do is replace the x with a 6. And I can easily see that y equals 0. And so my point is 6, 0. You could have chose the first equation and gotten the same result. But I see that y is already by itself for the second equation, and so I can easily tell that y equals 0. Those are all the notes for today. Numbers 1, 2, and 3 are all I'll go through for today. Next time we'll look at numbers 4, 5, and 6 and do those together. For now, what I'd like you to do is please turn to page 15, and you'll find problems 1 and 2 to be very similar to problems 1 and 2 on this page. I'd like you to solve them. You may work with someone, try to get an answer for both of those equations. Your answer for those two equations should be, for number 1 on page 15, should be 5, 1, and for number 2 should be 4, 3.